Okay, in problem number 3, we have the graphs of f and g given. We want to use them to evaluate each limit if it exists. If the limit doesn't exist, we explain why. And we need to show work on these. You don't need to show work on these, but you may. All right, what this problem is really looking at is the properties of limits. We don't have function definitions, we can't do it algebraically, but the properties of limits are here. So in part A, we have the limit as x approaches 2 of f of x plus g of x. And we learned from the properties of limits that that's just the limit, each individual limit, and then added together. So we say the limit of a sum is the sum of the limits. The limit as x approaches 2 of f of x is clearly 2. And the limit as x approaches 2 of g of x is 0. So then this limit is 2. Part B, limit as x approaches 1 of f of x plus g of x. Again, that's the limit as x approaches 1 of f of x plus the limit as x approaches 1 of g of x. The limit as x approaches 1 of f of x is 1. The limit as x approaches 1 of g of x, however, doesn't exist because the left is going to 2, the right is going to 1. And as long as any one piece doesn't exist, we say that the whole thing doesn't exist. In problem C, we have the limit as x approaches 0 of f of x times g of x. And just as the limit of a sum is the sum of the limits, the limit of a product is also the product of the limits. And so we have the limit as x approaches 0 of f of x times the limit as x approaches 0 of g of x. The limit as x approaches 0 of f of x, well, that's 0. The limit as x approaches 0 of g of x, that's roughly 1.5, but 0 times 1.5 is still 0. And we'll scroll up just a bit to get to letter D. In D, we have the limit as x approaches 0 of f of x over g of x. And the limit of a quotient is just the quotient of the limits. So it would be limit as x approaches 0 of f of x over limit as x approaches 0 of g of x. Again, the limit as x approaches 0 of f of x is 0. Limit as x approaches 0 of g of x is maybe 1.5. But 0 over anything other than 0 is just 0. Letter E, we have the limit as x approaches 2 of x cubed times f of x. And again, this is a product. It can be broken down into limit as x approaches 2 of x cubed times limit as x approaches 2 of f of x. Now limit as x approaches 2 of x cubed is just a plug and chug. We just plug 2 into x cubed and we get 8. Limit as x approaches 2 of f of x, we've already seen that that limit is 2. And so we're going to have 8 times 2, which is 16. Letter F, limit as x approaches 1 of square root of 3 plus f of x. And this is a function composition. Remember what we do with this is we find the limit as x approaches 1 of f of x, add that to 3, and then just take the square root of that. So since the limit as x approaches 1 of f of x is just 1, then we'll have the square root of 3 plus 1, and that's just 2. With letter G, we want the limit as x approaches 2 of g of f of x. When we're working with function composition, we take the limit of the inside function and plug that into the outside function. So that would be g of the limit as x approaches 2 of f of x. So the limit as x approaches 2 of f of x, once again, is 2. So that means here we just want g of 2, and g of 2 is 0. We don't want the limit, we want the actual value of 2 at the actual value of g at 2. And that's going to do it for the problem related to properties of limits.